problems are known for their life application, but just how this related rate used in life. Nobody has the desire to calculate the rate which rather fall, snowball melt, or balloon is blown up. Which related rate can help us calculate these things that are very trivial and don't benefit the world of math or science in any major way. So instead of trying to convince you that calculating the speed of ripple made by a stone tossed into a lake is valuable and real life, here I will tell you some examples that show the related rate is. For the first one, fuel tank of a spaceship. Mechanical maintenance arm of crew system use related rate to calculate the pressure and the quantity of fuel. It is because when the spaceship have launched, the mass of fuel in tank decrease, while the mass of nitrogen remains constant. The pressure of fuel tank is directly measured and used to calculate the quantity of fuel. To monitor this situation, MMACS must use the related rates. If you watch science fiction movie involving space travel, when the spaceship run out of fuel and start to crash, the captain knows the information thanks to related rate. Related rate also can use for a business. By taking different variables that connect to each other, a businessman can manage his company efficiently. For example, he can calculate how much product do he have to produce, how much workers do he has to pay, and so much more. So, by this application, the rate must balance with each other. Related rate also is related to a statistic. Everything in statistics is based on related rate. Conclusion: related rate is something seen every day as a concept, not just a mathematical function.
I will show you the example question of related rates. The question is, an empty container is filled with liquid. The head of the liquid in the container is x cm and its volume is v cm cube, when it gives v equal to x 5 plus 2x plus x squared. Find if the x increases at the rate of 0.3 cm per second, find the rates of change in volume when x equal to 1 cm. So the solution of this question is dx over dt equal to 0.35 cm. So we should write dx over dt equal to 0.35 cm. So the question want to find the rate of change in volume. So it means we have to do a dv over dt, which is equal to rates of change volume when x equal to 1. So we find the v. The v equal to x 5 plus 2x plus x2. So we simplified that to 5x plus 2x square plus x cube. We will get this equation. So when we want to do a dv over dt, which is we must do, so when we want to find the rate of change in volume, we must differentiate this equation in dv over dx. So we will get this equation, which is 5 plus 4x plus 3x squared. So when we get this equation, we will do the formula dv over dt equal to dx over dt times dv over dx. So dx over dt is a 0.35. So we will put this in this, which is a 0.35 times dv over dx. dv over dx is this. So we will get 0.35 times 5. This no x because we fill the x, we substitute the x with 1, like 5 plus 4x plus 3x square. So x equal to 1. 5 plus 4, we substitute this, plus 3, we substitute this. So we will get this answer. Okay, same, right? So we calculate this equation, it will become the 4.2 cm cube per second. So this is the answer. Thank you.